So very good morning to all of you. I will just start with the context setting session. We talked about the Viksit Bharat. So I would like to define Viksit Bharat with 3 E's. The first E is the economy, second is the energy, and important one, environment. If I talk about the economy, we are the world fastest growing economy and projected to continue with that. In terms of real term GDP, we are expected in long term around 5% GDP growth. When we talk about the growth, so now recently we have crossed the mark and became the 4th largest economy and not far away from becoming the 3rd largest economy in the world. Yes, lots to do to reach to the place 2 and number 1, but we have the vision. For every vision, for any economy to develop, you need energy. And India, currently the India energy consumption, if I will talk about in terms of primary energy consumption, 1 billion ton of oil equivalent we are consuming, and it is expected to increase by 70% by 2050 as per our outlook, and it will be 1.7 billion ton of oil equivalent. So that much primary energy consumption will increase in this journey of your industrial development or economy development goals. If I talk about this primary energy breakup, so the most of the energy currently we are consuming, it comes through the fossil fuel, even more than 70%. Either it is coal, either it is oil, or is a gas. Even if we see our efforts towards the net zero, all these efforts, we see there is a still significant component of fossil fuel will be the part of this primary energy mix. We are seeing around 47% coal consumption today in primary energy mix may come down by our efforts to the 40% actually. And towards the oil, it can be from 23% to the 20%, but yes, we are seeing a significant growth in the gas consumption as well as in the renewables, which are around 2 to 3% in primary energy consumption, may reach to the 19% with our efforts. All these things define the energy importance into the development, but yes, when you do the industrial development, it comes with your some responsibilities, some challenges. The challenges like industrial pollution control. So industrial pollution is the major challenge against the industries which are energy intensive industries, the other industries, the new growing industries like battery minerals, all these new industries. So we do have those challenges. And now the time has come, you cannot just do the compliance. It is a time to go beyond that. So today we have a panel, eminent panelist to discuss on that, beyond compliance, evolving regulatory expectations, and the smart monitoring frameworks. Either it is from industry side, or either it is from the regulators or ministry side. So with me, eminent panelists, so I will start with the introduction of Dr. S. Ranganathan, former Senior Deputy Director of National Metallurgical Lab. He was the head of process division there actually. And he is a very renowned man in the non-ferrous R&D. He has pilot plant commission on the titanium oxide technology, either it is on magnesium. He is part of various technical committees of the Government of India, either it is in a recycling of e-waste or recycling of other kind of waste. So he has that important experience. He is the doctorate degree from the India's one of the prominent institution, Indian Institute of Science, gold medalist from the Loyola College. So please welcome Mr. Dr. S. Ranganathan. With me, international environment expert, J.S. Kamyotra. Hope, sir, you are not jet lagged. So you are on the yesterday, just landed today morning. So he is a prominent and frequent speaker in the overseas conference, putting point of view of India, Vision India, when he was talking in our opening remarks. We will discuss on that, sir. He's having more than 40 years of experience. Former member secretary of CPCB. His dedication and contribution to the organization is remarkable. Parivesh Bhavan is your second home. We have Mr. Kishore Kumar Bhimwal with more than 2 decades of experience with Engineers India Limited. He was earlier. And he was the key contributor in the India's refining configurations, especially in the process design and the thermal design. When we talk about the thermal designs, it talks about the efficiency, energy efficiency, and it contributes to your industrial pollution control as well. So he is a key contributor to that. Currently, he is the part of one of the prominent organization under Ministry of Petroleum and Natural Gas. It's called Center for High Technology. He's additional director there. And currently contributing into the various role like committees related to site, strategic intervention in the green hydrogen. He's specialized in the green hydrogen. I would like to audience to please welcome all with a big round of applause to all of our eminent panelists. Sorry. So I would like to start with the industry expert and the expertise in the designing the refineries, Mr. Kishore Kumar Bhimwal. We are seeing there is an evolving regulatory expectation beyond the compliance when we talk about the net zero. So how do you see the future of refining industry configurations are changing? And if you would like to add into that, how the CHT contributing into that?
Okay, thank you, Gaurav, and thank you for your wonderful, introduction of mine. Before giving, a reply to your question, I want to say that I am attending many of the, conferences, and this is the one where we are discussing the main pertinent issue about the decarbonization and net zero. We are having conferences on green hydrogen, net zero, decarbonization, biofuels. Many of the, conferences are going on, but this is one of the, especially meant for the real issues which India is facing. So I congratulate all the, organizers first. So replying to your question, Gaurav, I think this is a time where oil demand is on peak. Means like refining, petrochemical, and the petroleum products demand is at peaks. And the reason are the efficiency improvement in the process refining, and the EV adoption, and further the there is a shift towards biofuels. So these are the some issues by which we can say that there is a oil demand is going to peak in coming years. Coming to your question that how refineries are evolving and change. Yeah,
exactly.
So as I told that there is a shift towards the oil. There is a less demand for the oil, but substantially there is a time where petrochemical intensity is going to increase in India. As of now, the petrochemical intensity is 6% somewhere. It is going to increase up to 15% by 2030. So there is a shift on C2C, crude oil to chemicals. This is a prominent shift which I can sense right now. And refineries are going to increase their profit margin by improving or by setting up such petrochemical complexes with the refinery integrations. Next, there is a biofuels and SAF also including. So now refineries they are thinking towards 1G, 2G ethanol blending. In 20% of ethanol blending has been successfully it is achieved. 19.6% blending is happening right now, which I feel that which will change the refinery configuration in future is SAF. Why I'm saying there is a stringent global requirements. CORSIA, CBAM, they are going to come by next year probably. So as of now, the total production of SAF is somewhere around 2.1 million metric ton. This is going to increase, eightfold, like 17 million ton by 2030. So there is a huge demand and opportunities for the refineries for this particular SAF. Next, as in my introduction, Gaurav told that I am from background where I am in the thermal equipment design. So I can say that electrification is going to play a key role in the refinery configuration. Like Uh, as of now, 3 to 4% of electric heaters are, used in the refining sectors. Government is thinking this 3 to 4% electric uses has to increase up to 10%. Our process-fired heaters or other, fossil fuel-fired heaters, how we can, convert into electric heaters, electric reboilers, or into electric motors. So this will change the refinery configuration in future. Next, I can say that energy efficiency by, optimizing the process crude preheat train which we design in EIL. By such efficiency measures, we can improve the process efficiency, and that could be game changer. It is a low-hanging fruit, I can say. Now there is a shifting towards fuels. So as of now, government refineries, they were using the fossil-based fuels for fired. Now shift towards LNG. Shift towards natural gas fired heaters. It is going to happen, and that our current gas-based economy, it is going to increase further. So this will also change the refining configuration. And very important now, the refineries, they are having very they are developing the hubs or integration with the petrochemical complexes. So I can put it like that the various CCUS projects which refineries are taking, they are setting up the integrated approach where there is a CCUS platforms available, integrated RE powers is available, and the green hydrogen is also available. So by all, I can say that the future in Indian refineries is going to change drastically by such measures. Thank you.
No, thanks, sir. Just one follow-up question on that, actually. When we talk about the refineries, there is one important corner in the refinery which call is a hydrogen plant. That is an important concern when we talk about the industrial pollution control or GHG emission. So what's your view how the green hydrogen is taking progress in the Indian refining industry, as well as it can be a game changer in other industry pollution control as well, like if we talk about the fertilizer, where it can be a raw material for making ammonia. So what's the specific role it can play, and what challenges you see in this?
So thank you, Gaurav. Again, very pertinent question and very close to me also. Basically in CST, we are handling a scheme that is called Site 2B. It is meant for the only refinery sector. So Site 2B is strategic intervention for green hydrogen transition. Total capacity allocated in this scheme is 200 KTPA, and the incentives is fixed. First year, the producer will get 50 rupees. Next year, subsequently 40 rupees and 30 rupees in the third year. These are the incentives provided by the government, and total outlay is for the PLI scheme for the hydrogen production is 2,400 crore under this Site 2B scheme. So what I can understand that first barrier or challenge is everybody understand it is economic viability for the refiners. So cost is high. As of now, everybody is thinking that cost is high, but there are certain benefits available using green hydrogen. So I was listening to Honorable Minister Puri Saab. He was saying that when he visit to European countries, they were selling or they were envisaging that green hydrogen cost it would be like $5.5 to $6, and our price discovery of less than $4. It is very, very encouraging for industry to come. So price is even though it is a barrier, but there are certain technologies are there by which we can reduce this $4 or $5 to $1. $1 is our target. So I can elaborate further also that how we can lower down this green hydrogen cost basically. So there is a possibility that currently electrolyzer cost is somewhere in the range of 6 crore per megawatt. I'm talking in terms of Indian rupees to understand easily and to digest also. So if we will able to, reduce it to 6 crore to 2 crore, that will give at least $0.75, benefit. And another thing is like the RE power cost. The main contributor in green hydrogen is RE power. 60 to 65% the cost which occurs, it is due to RE power. And currently RE power cost is somewhere in the range of, including the green cess I'm saying, 4 rupees 50 paisa per unit. So when we calculate the levelized cost of hydrogen with this 4 rupees 50 paisa to 6 crore for per megawatt electrolyzer, I'm taking some assumptions also in that, then the cost is somewhere in the range of 390 or 400 rupees. So it is okay, which we discover in this successful tender in the IOCL Panipat tender, which is the cost is 397. 397, right?
So, so you talked about challenges and you talked about the positive and the forward future thinking. Just taking from your words, actually, you talked about EVs, you talked about the biofuels. So coming to you, Dr. Ranganathan, actually, we are seeing the material transition, which is supporting this energy transition. How do you see the challenges in the formulation of policies, regulations, and the technological challenges? When do you see these new materials are coming, like we talk about the battery minerals, either the using into your EVs, or different new, as he talked about, the new petrochemicals or specialty chemicals. How do you see this, these challenges in talk about policies, either it's regulation or technology? Sure.
Thank you for asking this question. When we shift from the conventional energy sources to renewables, at present our focus has been mainly on reducing the CO2 emissions. But then what we are forgetting, there are two things which we probably don't pay much of attention to. Possibly you are shifting the emission from your industry to somewhere else. And the material production required for generating this renewable energy, that is going to involve a cost to the environment. Maybe in future, when CO2 emissions are going to become less of an issue for discussion or policy formulation, we are going to shift our goalpost. We are going to raise the bar, and probably we will start talking about scope 1, scope 2, scope 3, etc. for waste generation in general. That is solid waste or the impact on the environment. Maybe already we have this concept in industries. I'm talking, let us say, specifically with respect to metallurgical industries. We take into account the cost of emission, let us say from the mining stage onwards, when you are running, for an example, a steel industry. But then I also want to caution you, at any given instance of time, we have some data with us, we formulate policies, but then when you look back after implementing the policies, we see there have been a few gaps. I will illustrate with a certain case here. We have norms for particulate matter emission, which must be 30 milligrams per normal cubic meter maximum. Good. I find all the industries are able to comply with that. There's no doubt about it. And our records also show that. But then what we forgot is that even at this rate of emission, industries are emitting something between, say, 200 to 600 tons of particulate matter every year. Their volume of production and the gas which is emitted, the volume is so huge. And every time when there's a presentation for this, I'm wondering, I keep asking them, where does that 600 tons of particulate matter go? It gets dispersed into the atmosphere, but then we forget it. We have no modeling. We don't know where it is going to settle down. And its impact on the soil. I keep telling that this need not be a negative impact on the soil, because the point is that when you have acidic soil, maybe your particulate matter can compensate for the nature of the soil and can become even a nutrient. But we just don't have any data. But this is something which I missed probably, and I keep insisting that you have to keep monitoring the fertility of the soil in the vicinity of the plants, but then we don't know what is the number I have to specify, to what extent. And in this case, our smart technology like AI, etc., are going to play a major role. And I anticipate a similar case when you shift from clean energy to alternative energy sources. Maybe only when you implement, we will see issues which have not been anticipated. Very difficult to say what you are going to face. Of course, I can see one issue that how to qualify an energy is totally green. Because if you produce and replace a fossil fuel with something else, which is not totally going to be green, then we are a loser. That's going to be an issue. It's going to become a dispute also. We have to bring out policies to clearly define what is a green energy source and how we are going to implement it.
No, thank you, sir. You brought a very important points like challenges, monitoring, regulatory, all those things. Coming to you, Mr. Kamyotra, means like your close association with the CPCB, more than many decades, I will say it's more than 3 decades you are associated with them. What kind of transformation you see are required into the CPCB when you see the transformation happening across the industries? To these align with the shifting these regulatory expectations. What kind of these important, like as sir has mentioned about the challenges, the new industries, as Bhimwal sir has mentioned about that. So what kind of transformation you need in this organization for the journey from a regulator to a facilitator?
That's really a challenging question you asked. So as you know that CPCB came out with a roadmap for up to 2030. Many measures required to address the challenges coming during that period were imbibed in that document. But when we see the ground reality, there's a lot of shift, a paradigm shift from what was thought at that time and what is now, in terms of policy formulation even. So like Mr. Bhimwal mentioned about the hydrogen. Nobody thought about hydrogen at that time. And when we talk about hydrogen even now, as an example, we only talk about no pollution. But OECD is thinking about standards for hydrogen also. Yeah. So that means our vision has to be to meet those challenges which are likely to come up. So that is one thing. So second thing is when we talk about, because we discover hydrogen, so I'm just raising that. We talk about green hydrogen with green energy, RE energy. But hydrogen is a very water-intensive industry. And most of the places, we don't have water. So wherever we have desalination plants, we use there. Can't we have some other forms of, like green hydrogen with green energy? Can we have something with the sewage? Industry using sewage for hydrogen is categorized as one and given subsidy. It will help solve the problem of the area in treating the sewage, because hydrogen use requires 2 microsiemens of conductivity of water. So that is one thing. We have a lot of mine water available. If the mining sector in that area uses that water, which is mostly acidic in nature, mostly, if depending on the lignite mine or whatever it is, so it will help. So now CPCB need to focus on such areas that what are the challenges when we go with the new technologies, hydrogen or e-vehicle. E-vehicle, when we say that it's a zero pollution, but if you use the thermal energy, it's not a zero pollution, it's shifting all the pollution from one place to another. So we need to work very closely with the industry and the ministry, concerned ministry, in framing those policies which addresses those challenges which are likely to come, and they are very difficult to tackle in future, which as compared to what we have now. So I personally feel that CPCB should start working on developing documents in consultation with the concerned ministries, experts, that what are the challenges, how to address those challenges, what are the technologies which will give you the best results, like hydrogen again. Sir mentioned that the cost of 70% is the cost of energy. But if I can recover the heat energy going out, the cost is reduced. But I'm not doing that. So can I frame a standard for that, heat energy recovery? Can I frame a standard of recovering hydrogen which is going there, oxygen which is going out, and use it as a medical or industrial oxygen? It will save me a lot of cost. But I need to look that. And this is where CPCB need to enter to work on these strategies and technologies to address the challenges which we will be facing. Other thing is that when all these things are released in the environment, they create complex nature. VOCs are formed, oxygen is formed. So we need to work on those aspects, what will happen, the environmental chemistry, how it will change, and how we'll need to monitor them, whether we have the capacity or capability to monitor them. And like in the morning we mentioned the graph. If ozone increases, we cannot stop it. In the graph also, because we can't stop any activity, but it takes time gradually to reduce it. So VOC reduction, what are the sources? So we have to work on the emission inventory now, you see, which is missing in the country. Once we work on the emission inventory, we need to have the source emission inventory also, apportionment, that which source is contributing to what and what need to be addressed, considering the economics of the benefit adhered from that remedial measure. So we need to work in totality, and we need to have a foresight with discussion with the industries, the concerned ministries, the experts, the general public, frequent interaction, and international experts, and come out with the challenges likely to come, frame a policy for at least 10 years with in between review of the policy and revival of the policy, remodification, revisiting, whatever required to address the challenges if we are not able to meet and to generate reliable data, because unless these policies will not matter. So that's the expertise and capacity we need to develop in CPCB or other institutes associated or linked with CPCB, State Pollution Control Board, research laboratory, CSR laboratory, so that they can be a part of the total nature to do that.
No, thank you, sir, for the detailed explanation on that and putting the strategy forward for the CPCB transformation. I was just taking one word out of your today's opening remark. You talked about the trans-boundary monitoring, actually. You represented nation at the various forum. What's the importance of this trans-boundary monitoring in the current arena?
So, you have raised a very pertinent question. Because if you look into the South Asian countries, India is one of the major economy which has grown and has power plants. Sri Lanka does not have a thermal power plant, it hardly has a few thermal power plants. Pakistan has a very few power plants. Bangladesh just started with few power plants, otherwise they had a gas-based system and all this. Bhutan does not have a power plant. Nepal, no thermal power plant again. So, and the stacks of the power plant, you see, we have stacks of cement plant, we have stack of the refineries, we have stack of the petrochemicals, we have stack of the thermal power. But the stack of the thermal power plant is the highest as compared to all of these. So the zone of impact of thermal power plant is far higher than that. And when if you look into the environmental movement of the particles, something moves in the lower stratosphere, it's a different velocity, different direction, but if it moves in the upper atmosphere, it has a different movement fluctuation. So the things which go in the upper stratosphere remain there for many days and can even travel from USA to India. That can happen. So now these countries, always, because Lahore has a lot of environmental problem, worse than India sometimes, and they always base stubble burning from India, because Amritsar and Taran are just 30 kilometers from there. Their viewpoint is that India says that pollution from Taran or Amritsar is reaching Delhi, so why it can't reach Lahore if the wind direction is that side? They're right. In that way, they're right. Same thing is said by Maldives. This is the wind direction when it comes from the northwest. India is north of Maldives. Sri Lanka also, India is to the north. So it brings pollution from Tamil Nadu area, basically, and they have tried to show with imageries that yes, it is coming. Same is with the Bangladesh, it's happening. But since we do not have any trans-boundary monitoring stations, it's not possible to determine the impact. In 1998, a few stations were established along the border with Bangladesh at Port Canning, with Sri Lanka at Tirunelveli, with Pakistan at Dera Baba Nanak. So they were established. But one station is not adequate to project the transboundary impact of pollution. And at that time, after that, because there is no data sharing, there is no quality assurance and quality control program, so all the data that is generated by these laboratories are of different levels, so it cannot be compared, so it was not agreed. But yesterday, in the meeting of SAKEB, SAKEB is the South Asian Cooperation on Environment Program, so all the 7 countries are members of that under Male Declaration. So it was agreed that we need to work on data quality, data assurance, have common SOPs for monitoring, common SOP for analysis, and ensure data sharing on the same platform, so it can be compared, and in case of any such issues, it can be discussed. But it's a major challenge. You need to have a number of stations if you want to monitor transboundary pollution, and not manual station, but continuous station. Then only you will get the impact, and the location of the station is very strategic if you want to monitor the transboundary pollution moment.
No, thank you, sir, for this explanation on the transboundary monitoring importance. Moving forward to Mr. Kishore, we discussed about the transition is happening. The industries are investing into these energy transition, green fuels or green industry, GHG emission control. But there is a requirement of always comes, you have to incentivize the industries which are taking initiatives. You have to penalize who are not taking the initiative. There is a very holistic scheme which has replaced PET scheme, has come, this carbon credit trading scheme, which is a carrot and stick kind of approach where you are, if you are saving your emissions, you will be, means like getting certificates, you can trade that carbon. But if you are not, either you have to purchase or either you will be facing the penalties. What kind of challenges you do see the implementation of this scheme in the current arena of the, means like if we see the infrastructure and all those things. So what kind of different challenges and the opportunities do you see?
Thank you, Gaurav. First, I, wholeheartedly welcome Mr. Kamyotra's suggestions regarding the, green hydrogen. So I can say that a few of his suggestions already taken care by the ministry, and we are taking care. And one is like he's talking about utilization of byproduct oxygen. So you can see that in the IOCL tender we have mentioned that the excess byproduct oxygen they will buy. Means it is already mentioned. So refineries they are using, because there are multiple uses of byproduct oxygen also. So we are already taking care of such suggestions. Welcome, sir. Huh? Yeah. So coming to your question, Gaurav, CCTS, what I feel now, it is basically we should not confuse with it as a PLI scheme. It is not a PLI scheme. It is a market-driven scheme, which as you said, it is penalized to those who are more polluters, and incentivize who are less polluters. So it works like that, and the market works accordingly. So yes, but there are certain challenges in CCTS. Number one is price volatility. So I think there should be a robust price mechanism under CCTS, as we have experience in the e-certs and RECs. There was excess supplies of RECs, and there were low demand. Because of that, I think many of the RECs and e-certs, they are untradable as of now. So this is my first point, that it should be taken care. And this price volatility, how we can manage by like price ceiling and price flooring mechanism. I don't have that much
Exactly.
Anyway, but it should be included. This is my point. Now, I was involved in target setting for the refinery sectors. So target setting is very, critical area because you don't have sufficient data of the refineries, how much they are emitting. If they are emitting also, then they are not, putting in front of the agencies. So my point is that lenient target setting and, very stringent target setting, both are, it not going to work for the CCTS. If your target is very lenient, then everybody will achieve their emission targets, and the e-certs, carbon credits, their price would be low. If everyone is achieving their target, then the supply will be very much. So we should leave it to the markets basically. Now another point is availability of the data. So MRV that we called is monitoring and regulatory and verification points. MRV is very critical, and for MRV, I think blockchain technology can play a significant role. Blockchain, we have introduced in CCTS also. It assures that there should not be any fraudulent activities. You can, every time you can check what is the status of your tradable certificates. Everything is taken care. Now greenwashing is again, it is a challenging. Some companies, they are claiming false projects, they are putting false projects. So greenwashing is a challenge, and for that also I think AI, AML, IoTs, these technologies will help to the industries. And very important point is aligning with the global certifications or regulations. So our CCTS, it is aligned with the Article 6.2, which is, Paris Accord, it says. So it is aligned with that also, and it also works for the various, trade barriers like CBAM and all. So we are taking care each and every part so that the industry won't suffer. So my point is about the CCTS is that the policy should be in such a way that it takes care of the environmental goals as well as the priorities of the industries, their economic welfare. So it should be balanced. It should take care of the industry as well as. These are my certain points about the CCTS.
Well summed, and you brought a very important point about the MRVs, and I will come back to you, Dr. Ranganathan, on that. When we talk about the MRVs, monitoring, reporting, and verification, how do you see the necessity of the digital technology, AI, big data into this and the success of this scheme?
Yeah, before trying to address this question with respect to CCTS, the government is also trying to encourage green credits. And it has got a broader base because every individual, every common man or organization take part in that. And they are not technologically savvy. And there's going to be a challenge for us to monitor, report, and then to do the balance. And there are going to be a lot of challenges in regulating that and making sure it is going to fall in line. But I think the green credit scheme is an excellent one for the simple reason it makes everyone aware of the issue of environmental impact of our activities. Then monitoring, reporting, and then verification, etc. I always have a second doubt about the CCTS scheme. Let us say an industry is so comfortably placed, it can buy carbon credits, keep running it without bothering about what it is emitting in a specific locality. How is it going to affect the local, let us say, environment as well as the climate in that region? How have I even thought about it? I think these are the regions where the AI and the smart technologies are going to play a very, very important role. In fact, I strongly object even when somebody is trying to put up a kind of, let us say, waste mound, ash mound, or let us say tailings. I point out one thing, that you put such a tall mound there, and we are going to definitely obstruct even the wind pattern. Have you ever thought, have you ever modeled, because your mode is going to be for 10 years, 20 years, 30 years, it definitely is going to affect the ecology in the local region, particularly with respect to the climate. This is an issue which probably will be tackled, because the most important or interesting thing about AI is that it is very dynamic. It can keep on train itself very fast and then keep producing results for you, which are going to be more and more accurate and then going to be dynamic, and then we have to keep pace with the system, with the technology, to make sure that our policies are also evolving fast in this regard. Okay, then I want to say something about what our friend said here about cross-border monitoring. You please give an opportunity at the end.
Okay, sure, sir. Sure, sir. So, sir, coming back to you, sir, actually, when industry is transforming, when we talk about the digital transformation, you always the front leader for the modernization of the organization or the processes, monitoring the frameworks. So how do you see the role of digital technology in framing the smart frameworks at the CPCB or the state pollution control boards?
If you see the growth of economical growth and the industrialization that is taking place, there is a wide hiatus between the capacities at the boards. So at the present level of capacity, it's nearly impossible for the boards to keep a track of all the industrial emissions unless they imbibe the IT technology in the system. Now, IT technology has its own challenges. We have been using manual monitoring techniques, we have been using the online system, but still there are wide gap in the data quality, reliability of the data so far. And when we talk about the IT, maybe AI, which thinks about, in the layman language, as a person thinks, it thinks that way, or the machine learning language, which generates the algorithms, or the DS, which generates the pattern and projections. Now, what is the basis? Is the data. If the data input is not correct, everything will be wrong. Now, all these capacities in the AI, unless whatever you feel, it takes from that and tries to address the situation, come out with a solution. Take an example. If we are teaching a child that what is an apple and what is a melon, he is able to just see the size and identify these two. But AI, for doing that, needs to have multiple exercises to do that. And that takes time. That takes time. If you overload that data, again it is not able to decide what to do. If you have a less, it's not able to understand what you want. So we have to develop that capacity and capability in the organizations now based on IT, that people understand what they want, what is the policy it will give me, how to use that policy for further growth, and how to match this. Because when I say that the data is based on algorithm, because AI is based on ML, again, and uses the algorithm. So once it uses algorithm, I can manage any algorithm, I can have IoT, I can manage the source code, I can do anything. But first thing and foremost thing is the SOP should be very clear that it is a transparent mechanism without manual interference anywhere. So that means whatever data you get, X quality, Y quality, it is coming directly to the computer. And it is processed there without manual intervention. And then the algorithm takes over, does the work, come out with the projection, and this. So once such type of capacity building takes place, yes, we can think over that, shifting from that, and that is the only way. If you look at present, we are able to monitor just 400 cities in the country out of the more than 5,000 cities, and then we say 131 are non-attainment. So if I monitor 5,000, it may be 2,000 cities are non-attainment. So I don't know what is happening. So instead of waiting for a system to be developed, which is robust system, you say, we can have a system which gives me a data at least for trend analysis, for accidental releases, for health impact, or for assessing the need for monitoring in that area, at least for this basic purpose. But this cannot be accomplished unless this is imbibed in the regulatory regime. Because the National Ambient Air Quality Standards of 2009 clearly specify the method of monitoring. So unless they are re-notified, incorporating this, it cannot be taken in the regulatory regime. But the challenge comes now. The accuracy of data, uncertainty of data is very high. So we have to be very clear that what is the purpose for which this data is being used. This data cannot be used for regulatory mechanism or closing the internet, first thing, because uncertainty gap is very, very high. Or we agree that this data with plus minus 10%, 50%, whatever is accepted for all such purposes. We need to define that. Otherwise, public will always keep on raising that, oh, 400 micrograms, the air quality is bad, then it will be a problem. So we have to be very clear the purpose for which such systems are used, unless the quality is very, very reliable based on the algorithm again, you see.
Yeah.
If the algorithm is very good, yes, you can get a good database. Same is true with the low-cost sensor. Most of the low-cost sensors are based on algorithm rather than based on the sensor. So we need to work on that, come out with a robust system where uncertainty is defined plus minus 20 to 40% is acceptable for trend analysis, this for health, this for this, and this for this. So then it can be good. But that is the need to ensure that we get data covering the entire country. And such initiatives have been taken by UN agencies. UN SCAP is working on geospatial air quality information system with countries like Pakistan, Bangladesh, Nepal, India, Sri Lanka, and Thailand, and such around 20 countries already. So we can become a partner of that, start getting the information, developing expertise, and put it in our system.
No, thanks for highlighting the importance of selectivity of data. That is a need of our. You have to be selective and taking out the meaningful insight of it, actually. Yeah. So coming back to you, sir, you want to some comment on that, and then we can take some 1 or 2 questions from the audience.
Yeah. When our colleague pointed out about the cross-border mechanism for measuring the pollution impact, I'm not talking about that. This had triggered a thought which I've been trying to highlight with the industries. When you have a cluster of industries, each one is trying to claim that his pollution level is within the norms, much lower. But he says the next one is polluting it more than I do. And we really don't have a model or any mechanism to verify. But ultimately, the people or the ecology around is getting affected by this. We have to give a thought to that also.
Yeah. So at one time, it was thought that rather than asking each industry to establish 3 stations, let these stations be established in the entire vicinity, and a source apportionment be done, because every industry, when it emits, it has certain characteristics. There is a correlation between the pollutants that are released, like power plants, molybdenum, all these are coming, and their age can tell what is the distance they have traveled. So if I can do that type of fingerprinting, and then when I monitor it at one place, with the fingerprinting data I have and the monitoring data I have, and comparison of interrelation between 2 pollutants which are coming, because every fuel has a different characteristics. So markers, we can use those markers to identify which is contributing what, and then clearly pinpoint that this is coming from this industry. And then now presently most of the people are using dispersion modeling. We use the receptor model then to counter validate that what is happening, that if I get this is the data, then what are the emissions coming from that industry. So immediately I can find out. And in addition, if I want, I can put the predictive modeling also, that in case the SEMS is not operating, this is the level of emission which is likely to come, and this will be the air quality impact, and with the receptor model I can back calculate and come with the source of pollution. It is possible, but it requires time. It can be done. Thank you. I hope that addresses your question.
Yeah, but I believe the implementation is very important.
So we are coming back to the audience. So like we can have 1 or 2 quick questions by considering the time. So yes, please. Yes, please. Can you please provide mic to him? Can you please introduce your name and organization?
Yes, sir. Namaskar. I am Dr. Jagdish Shivahare, professor and ex-scientist ISRO. Sir, my question, how...
Prashant sir, if you would please come to the dais, actually. We'll request you to come to the dais. Sorry for interruption.
No problem, sir, please.
Yeah, please continue.
Yes, sir. I am Dr. Jagdish Shivahare, professor and ex-scientist ISRO. Sir, I have a question. How is the industrial pollution control strategy in India different than developed countries in terms of pollution control model, smarter monitoring and regulations, and ecosystem implement challenges?
Sir, I think you would like to answer on this. Can you repeat that question? So the question is that what's the comparison between India's monitoring of industrial pollution control and the developed countries having smart monitoring system and reporting system? So he wants to ask about the comparison on that. Is I'm right?
Yes, sir.
So if I rightly understand, you are talking about the industrial emissions, right?
Yeah.
Right, sir?
Yes, sir. Just
Yeah.
a difference. Industrial pollution control. Sir, please, I read
Yeah.
the question again. How is the industrial pollution control strategy in India different than developed countries in terms of pollution control model, smarter monitoring and regulations, and ecosystem implement challenges?
Okay. In India, there is a difference. You see, we have set standards under the Environmental Protection Act, and each industry is required to comply with the standards on 24/7 basis. That means every time. Okay? There is no provision of uncertainty. If the standard is 30 milligrams, it has to be 30 milligrams. The reason being, when the samples were being taken, it was one-time sample taken manually. There was no SEM system installed at that time. So the standards, the law clearly defines the method of sampling. It says the sample need to be taken and to be divided and given to the industry also if required for that. So it does not talk about sampling with the SEMs. And because the sampling method is very clearly defined, so SEMs are not part of the regulation because they get you the data, there is no sample collected virtually. Okay. Now, since our standards are not technology specific, you see, when we develop the standards, it are based on techno-economic viability. It has to be technically viable, economically viable, the industry has to be compatible, and we need to have the monitoring facility or infrastructure also with our regulators to monitor that. But when you look to EU or USA in that matter, they never talk about one value. They talk about that even in SEMs, we say that there can be a spike for 2 minutes or 1 minute spike can be there in our SEMs, continues. But those countries, they say moving average. They talk about moving average. Over a period of 8 hours, yes. But half an hourly, if the values exceed 200 times also, it is not a violation because SEMs will never give you a one-to-one correlation with the chemical method. So the system is very different. They have a regulation, but they have a relaxation for the industry for any mishap happening in the industry or any process problem happening in the industry. But this averaging is 8 hours. In US, it is a moving average. So moving average in 8 hours, the value has to comply with. So even there are spikes, still you will comply because ups and downs are there. And if people are there from cement industry, is a typical example. The NOx values exceed drastically, up and down, up and down, up and down. So that's why their standards, when they were given 600 standard, they were not willing to accept that as a standard. So because their standards go up to 1800 also. If the plant has some problem, go to 1800 also, the wide fluctuation. But that provision is not there in our SEMs. The reason none of the industry raised the point where the standards were, when it was, the guidelines were notified, and everybody accepted it on the platform. When it was discussed, everybody agreed, yes, we'll meet it. So now they say we can't meet it. So these are the things, when they are developed or designed, you have to come up with a viewpoint so that they can be taken care of. Just like I'd add, now in the recent amendment which came for the Water Act and the Air Act, and for that matter, the siting criteria is defined, that any industry within 500 meter red category from the river high flood level is not allowed. Yeah. Now, once this condition is in the consent, it relates to EC also, because you can't get consent after EC now. But nobody raised that point when the draft was notified in July 2024, but when implementation started, everybody is raising a point. Yeah. So, since we are at a forum where we're talking about the future and how better, what to do better for the industries and the environment, exactly. My request, suggestion is that just raise the points when these are notified draft form so that it can be addressed. After notification, it becomes very difficult to address.
No, exactly, sir. You sum up it very well, actually. We have been joined by very senior environmentalist, Mr. Prashant Gogate. He's having more than 15 years of experience in environmental management organization. After that, he is currently heading the Reliance Environment Department. He is having more than 3 decades of total experience. He is a chemical engineering graduate from India's one of the best institution from IIT Bombay. Sir, you joined us, so just I want a very quick comment from you. We are discussing about when beyond compliance. So how do you see the importance in the current arena? We should go beyond the compliance and moving the regulatory expectations. So what's your take on that, and if you can sum up in a few very quick comments?
Yeah, hello. Sorry for joining the session late. Actually, beyond compliance is a concept which, number one, needs to be understood by people who are following the standards. Typically, like if you see, like you take the example of a power plant. If a power plant is at say 500 megawatts and with a flue gas emission of about 20 lakh nm cube per hour, the standards, even though they are 30 milligrams per normal cubic meter for particulate matter today, at an emission of 1 milligram per normal meter cube, the plant would emit about 14 tons of particulates annually. So which means that even though the standard is at 30 milligrams per normal meter cube, voluntarily, if the unit takes some steps so as to at least reduce their particulate matter emission by even 5 milligrams per normal cubic meter on a sustained basis, they would end up belching out 70 tons of particulates in the atmosphere every year. So that's what beyond compliance is.
No, thank you, sir, summing it up. And our experts will be whole day here. Can I add something? Yeah, sorry, sir, please.
Can I add something?
Yeah, please. Just we can have a quick comments from both of you.
Please proceed.
Yeah. When the SEMS was introduced, it was introduced as a tool for self-compliance and self-regulation. That the command and control should not be there. The industry should see for themselves and ensure that they are complying. But the concept behind was beyond compliance. That when the industry is inspected by the board people and they found violating. So that means it has been violating over a period of time and damaging the environment. So when SEMS is there, that the immediately industry knows that, yeah, they had exceeded the compliance. So they can take remedial action immediately. So saving on the environmental damage as well as the cost on the operation of the air pollution control device or the environment. Second is, if you have 2 plants with the same capacity, just what Prashant ji mentioned, 200 megawatt 2 plants, and one is giving me emissions of 40 and another is giving me 30, I can correlate now. Why it is giving me 30? So I can have a resource conservation, that means energy conservation. And when I conserve energy, that means I reduce the carbon footprint. When I reduce the carbon footprint, because pollution and global warming and GHG are all interrelated. So I reduce the GHG also. So indirect benefit I get for all this. Third thing, when this data is available with me, I can show to the public I am compliant. My market image can improve. My complaints will reduce because transparency is there in the system. And even the board, people when they come, they cannot say you are not complying because that data is available to them. So this was as a tool that in future we should stop monitoring rather than believe on per se the data that comes from the industry and take it as a true value. So that's why I said so beyond compliance.
So very quick comment from Dr. Ranganathan.
Coming to the issue that was raised, that is, even if you reduce a particulate emission by 1 milligram, you can reduce the total emission by about 70 tons. I mean, right at my first comment, I raised the same point that our industries are emitting about 600 to 800 tons of particulate matter every year. And the industries are going to run for, say, 50 years minimum. And you can imagine what's a huge amount of particulate matter they are emitting. But my point is that this is again a question of beyond compliance. They are complying with our requirements, but they are not calculated beyond that. I wanted a simple answer from them. Where does it go? Have you at least modeled it? When it is emitted in the atmosphere, where is it going to settle down? I had a very casual answer from somebody. It is going to settle down somewhere. That's what he was telling. They don't have an answer for that. And coming to the beyond compliance, I will give another example. An industry was discharging treated water from the industry into a river nearby. It was giving the same water to agriculture also. And both are permitted by the Pollution Control Board. There is no doubt. I was asking them, are you complying with the PCB norms? They showed me a data. All their analyses were perfectly matching or less than what was expected from the PCB. But the total dissolved solids was, say, something like 1,000. And when I add up all those analyses, they are coming to only 100. I said, where is the risk 900? He said, no, sir, it is complying with the PCB norms, and I don't have to care about that. I objected. I said, I am not bothered, because the PCB, when it drew up the norms, probably was not aware there is something hidden here. I want to know what exactly is hidden. Please analyze for all the radicals and tell me what is happening. This is again a question of beyond compliance, because they complied with that, but the industry did not bother that they are doing something more, which they should have been conscious of or be responsible enough to comply with.
No,
Or to at least apply
thanks,
them.
sir, for this very interactive session. Actually, if I would like to sum up in very one line, India is transforming, industries are transforming, and there is an immediate need for going beyond the compliance. And then we can make the profitability out of the sustainability. Thank you very much to all. Please welcome all of our panelists with a huge round of applause. Thank you.